Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this lecture of this ongoing online course on Engineering or Architectural Graphics Part 2, where we are learning about how to draw isometric and axonometric projections. In this week, we are learning about how to draw isometric drawings, how to make isometric projections for different objects 2D and 3D. And in the previous two lectures of this week, we understood the fundamentals of axonometric drawings. And we also saw how to draw axonometric projections, axonometric drawings of 2D objects, the planar objects. So, today what we are going to do is we will look at how to draw the axonometric projection of prisms and pyramids. I am taking it very fast because we have already gone through how to draw isometric projections of the same objects, and I am trying to keep the same examples, and we will see what difference does it make if we are doing it in isometric projection versus axonometric projection. So, this is a square base prism and we are going to be drawing the axonometric projections of it. So, this is square. I will change the ink color. This is the square, which is what we will see as it is if we are assuming that it is kept perpendicular to the HP and the face is parallel to VP. And now all we have to do is just extrude it to whatever height is given here. Okay. Now, just as we do in isometric, we can get any one reference line and then draw rest of the parallel lines, or we could draw all the lines and then draw. So, very simply this is how we are going to view this object in axonometric, which is a simple square based prism or a cuboid, which is kept perpendicular. This will be dotted, it is hidden behind. This is what we will see. Now, what if I am just assuming the same object in different conditions? So, what if it is kept parallel, the axis being parallel to both HP and VP? So, what we will have? We will first have to draw the square, which is this base. And now, this is what we will get. So, it appears very similar to this, but here you can see that the square does not remain a square, but here we can see that this rectangle, which is parallel to HP, the angle remains 90 degree here, just that the plan is rotated. We could start from anywhere. We could have started from the rectangular base and then projected the ones upwards, or we could start from the square and then do it. Whatever is convenient is what we will draw. The same we can do if we assume that the axis is parallel to HP and perpendicular to VP, and we will get. So, I can start by drawing a rectangle which will have just this rotation like this. So, 90 degree, and then we can project it upwards. So, we could actually do it this way too. So, either ways you have to see where will you start. Often drawing the plan in axonometric is easiest. This is a cube which is now tilted. Now, we will have to see how do we start drawing it. So, I will make a reference rectangle here, which is enclosing the base of this cube. Okay. Now, this cube is inclined. So, this is what we are going to make first. Directly we could draw, but then you have to get the angles. So, if I have this line which is a reference at 45 and another one at 45. So, this is again the enclosing square which we are getting here. And we could get this. Okay. Now, you can see here that the angles will remain the same 90 degrees. There is no change in the angle that we were seeing here in this plan versus what we see in axonometric. And now, we can raise the heights. And this is what we will actually be seeing in axonometric if we were to view this inclined at 45 degrees. This angle is given as 45 degrees, and now you can see that 45 degrees of this and 45 degrees of this. So, if you rotate this by 45 degrees, again this is what we are going to get, a perfect square, and then raising it, it does not look very clear. It does not give us a very clear idea of what this 3D object is. In fact, for such a cases, the isometric will give us a better idea. Okay. Now, if we were to draw it in some other angle, then we would get a slightly skewed object, but the moment it becomes 45 degrees, we will have a little problem because a lot of lines are going to be hidden behind these vertical lines which have apparently become vertical. Look at another example here. So, we have this quadrilateral here, slightly different. Now, what I am going to do here is not take the distances. So, assuming that we know how much is this length and this angle, we can draw. So, what we can draw is, I will draw QR which is at 45. So, this is QR at 45, and then we will make another 55. Okay. So, 45 and 55 parallel, whatever that distance is, and then we join again. This object that we will get will be exactly having the same angles and same dimensions as this given object, which is what we will get here. So, E, F, Q and R, and then we can give the projections. Whatever the height is, you can then take them. Now, suppose it was inclined, which is what we will see in sections. All we have to do in this case, in that case, is that we have to measure the heights, whatever the respective heights are, and then we can join. Look at this triangular prism, which is kept with one of its rectangular face in the HP. So, I am going to start by drawing what I see here in the plan. Okay. So, very simply what we are seeing here is a rectangle, a simple rectangle, and I will also draw this line. Okay. Now, if you look at this from the side view, we very clearly see that this point, which is what we are seeing here, has a certain height, while the other ones, they do not have any height. So, we can keep them as it is here, and all I am going to do here is raise this. So, whatever the height of this point is, we raise. There is certain height to this point also. Okay. So, this is what it is, and we can simply join. We do not need to draw the reference rectangle or anything like that. I have not even drawn what this triangle separately or anything. All we have been doing here is whatever is seen in the plan, we draw it as it is, and then give each point its respective height, which is what we have done, and then we joined. If you want to verify it, you can actually draw the rectangle, bring it back here, and you will see that it is exactly what we have got here, even without going through the rectangle route. So, you can simply, this is what we will see if we are to draw this triangular prism, which has its axis parallel to both HP and VP. This is what we are going to see. You can assume it in other positions also. The process remains exactly the same, that you draw whatever is being visible in the plan and then give them the respective height, which is what we were seeing when we were discussing the very first lecture, that we draw whatever is in the plan and then give them their respective heights. We will do the same thing here. I am just going to draw the plan and then give the respective heights. So, what we have here is a rectangle like this. This is the rectangle that we see, and I am going to draw these lines as well. So, this is the line, this is another dotted line. So, what we could have done is we could have just picked this and rotated it by 45 degrees, which is what I am going to, which is what I have done here. And now we are going to give them heights, the respective heights. So, what we have here is that these points here, 4 of them, they have certain height, which is this. Okay. So, we just raise them by that height. This line I am drawing because I am not measuring. So, just to ensure that we take the same heights, that is it. But there is, do not confuse that I am actually making rectangles, I am just taking the same heights here. For these points, for these 2 points, we will raise it further. So, this is the height that we get, and the same thing we can do here. We have certain heights for this, and for these points we have no height, this is 0. Okay. And now all we have to do is join these. So, I will start joining from the front. This is what we will see from the front, and now we can draw the parallel lines. This is what we will see for this pentagonal prism, which is kept with its axis perpendicular to VP and parallel to HP. Now, all we have done here is we made the plan here in the bottom, whatever that plan was, and then gave respective heights to each individual point, which is what we got from the elevation. We can do the same. So, this is what we saw here. We could have done the same thing, exactly the same thing with other positions, and we will try doing them here, so that you understand that the process remains the same. I am going to draw this rectangle, this one here, the case B. A we have just seen. This is the rectangle, and this is the line that we are seeing in the plan. That was the axis. Okay. So, this is the line. Now, what we are going to do is have different heights to all these points. So, this one is at 0 and there is another point above it which is here. For this point we have say this, again 1 0 here and say this one here, and then for this one we have again 2 points lying on the same vertical line. So, say one here and another one here. So, these 2 points here and 2 points here, and now let us just join these. Whatever is visible in the front is what I am joining here. You will see if you follow the process which is given, say slightly if it was off, we could have actually seen this. And you can also arrive at the axis, say it was here, and then you can just take the height for the axis wherever it is, and you can actually draw the parallel line. So, this is the axis. We can also arrive at that very simply by following this process. Draw the plan, rotate it by 45 degrees and give each point its respective height is how you will arrive at the axonometric view. This is again very simple. I am not going to redo this. This is a hexagonal prism, exactly the way we did the pentagonal prism. You are going to do that. Start by drawing the plan, inclined at 45 degree and give respective heights to each of these points. Okay. Now, let us try to draw this triangular pyramid, and let us see how do we start drawing the pyramids. So, what we are going to do here is, without thinking, we are just going to draw this triangle here. So, we can make it by enclosing it in a rectangle if we are going to start like this, or I could start by drawing this line which is at 45 degrees here, okay, and then I know how much this is. So, we can just derive this triangle. Okay. So, we can do that as well because it is simple like this, and now we also have to arrive at this because this is not the complete. So, this is what we saw in plan, which is what I have drawn here. This is the point O. Now, if we look at it in elevation here, we can see that A, B and C, which is these 3 points, they have 0 height. So, they are going to be where they are, and this point O has a certain height which is this. So, I am going to give this point O a certain height which is, say, this. This is the point O dash. Okay. Now, I have arrived at all the points. All I need to do is just join them. This is what we will see as a triangular prism, a triangular pyramid. The simple thing about axonometric is there is no difficulty in drawing the plan. Whatever you see in the orthographic is what you draw here and just provide them with the height, which is what I had done here, and we arrive at the 3D, the axonometric of this pyramid. You can look at another example, and I am directly going to draw without any reference rectangles here. So, what we have here is, again you can see that this is 45. So, if we were to draw it directly, this one will be seen as 90, 90, another 90, 90 and 90. this is what we will see of this square if it is inclined at an angle of 45 degrees, and I am assuming this is 45 degrees. So, we will get a square, the same square. So, B, C, D and A, and join this, arrive at O. Now, what we have is that A, B, C, D are all at 0 heights, and this O has certain height, which is what I am going to take here. So, this is where your O dash is going to come, and that is what all the points are. Now, we have to draw the edges and we get at the final object. This is what you will see if we are drawing this square base pyramid in axonometric, and here this square base pyramid was inclined to the VP by 45 degrees in the plan itself. If it was kept parallel, in that case our 3D visualization in axonometric would have been different. Let us quickly draw that as well. In that case, the square would appear to be rotated like this. This is the square that we are talking about. And this is where the apex is going to come. And now, when we join this, this is what we would have seen, and this becomes your hidden line, and the edge which is joining this point and this is going to be hidden at the back. So, this is what we would see. I would remove the green lines for your convenience here. This is what you are going to be seeing if we are seeing it in axonometric. This one here is inclined at 45 degrees in plan, and this one is parallel to the VP. So, for the same pyramid, different positions, you can see the difference we get in axonometric. Now, this is a pyramid, square base pyramid, the same pyramid which is now having its base resting in the VP. Now, what do you draw here? If you follow the same procedure, we can again arrive at this. So, what I am going to do here is, but we will have to actually take the square in VP. What I am going to do here is just taking the heights through the plan and then arriving at this. Now, I am going to draw this first, 45 degrees. This is the axis which we get. On this axis somewhere is this O, B, C, D and A. Okay. I am just replicating the plan here first. This is what our plan is, which is what I have drawn in axonometric, and now I am going to give them height. The D is going to be in the HP, which has 0. A has a certain height which is here. So, I raise this A, I get A here. Okay. C has a certain height, I get C here, say A is somewhere here. D is at 0 and B is somewhere here. Okay. Now, if I will join this, we will arrive at, I might not be able to get the exact drawing to show you here, but we will get the parallel lines when we just raise them. Exactly, this is what the base is going to look like. If you draw it in elevation first, you will still be arriving at the same thing, which we will get if we are extruding the plan and arriving at these 4 points. And now, this is O. If we have to arrive at the, so I will change the color, we will just draw this is the square base pyramid which is perpendicular, and we can also get the height of the axis which is say here. So, you can draw the axis as well, and this is what we are going to get. And if we just join these, you will see that you have actually arrived at the correct point. So, you could start by drawing the elevation and then bringing out the apex or the lines which are perpendicular to VP, or in all cases this works, drawing the plan first and then extruding all the points, however complicated the object may become. So, we will see the examples. This is again very simple. You have to draw the pentagon very simply and then extrude the point O, and you get. We do not have to draw any reference rectangle or any reference drawing. Try to draw it on your own at home. This is again the same thing, just the pentagon rotated. So, you have to start by drawing this 45 degrees line. I am assuming that this is how we are taking it, and then you can take the same angles, or you could make a reference, okay, for easy drawing, or you could just draw the pentagon with this as a side. So, you will arrive at the same base shape, okay, and then you can just extrude them. You can also arrive at this point O, extrude it and draw the pyramid. This is again a very simple hexagonal pyramid. We will draw it again simply by making the hexagon first. The reference could be any. So, you could take a side like this, or you could take a side like this, okay, and then you can actually draw the hexagon. Draw the hexagon, and draw the arrive at the apex and get your pyramid. Okay. So, drawing pyramids, drawing prisms is very simple in axonometric if we are starting with the plan or any elevation, either ways, but drawing them with plan is what you should try when you are doing the axonometric drawing. So, I will stop here. That is all we are going to cover in today's lecture, where we have seen how to draw prisms and pyramids, and we will look at some more 3D objects and then combination of these solids in the remaining 2 lectures of this course and this week, which is apparently our last week. I hope you are following how to draw axonometric drawings, and whatever queries you have, you can post to us on the discussion forum. I will try to resolve them as much as possible. Thank you very much for joining with me today here. Have a great day. Bye-bye.